This is problem 61 of Neetcode 150. Kth largest element in a stream. So we have to design a class to find the kth largest element in a stream of values, and this stream might include duplicates. So in this example, we have to find the second largest element, and we can count duplicates. So the first largest element, starting from the end of this sorted list, is 3, and then the second largest element is also 3. Okay, so we're gonna have to return 3 if we have this array. So we're gonna have to implement the constructor, which is gonna initialize the objects and the integer, and we are also gonna have to create a method called add that is gonna add the integer value to the stream. So with that being said, let's consider the different options that we have. First option is that we for every values that we had, we are gonna add it to the n, and after each addition, we are gonna resort the array in ascending order, and then we are gonna give the kth largest element, or the kth element starting from the end of the list. But this is gonna be quite expensive in time because we are gonna have to sort the list every single time we add something. So a better option here is to use min heap. A min heap, basically, it's a complete binary tree where the top values or the parent values is strictly smaller or equal to its child. So for example, I have 1 here, so I could not have -5 here as a child. This is not a correct min heap. So I could have, for example, 2. On the other side, I could have 4, right? And the child of 2 could be 7, for example. So what I'm showing here is a valid min heap. What will be an invalid min heap is if I add -5 on the right child of 2, or if I add another child to 7, for example 9, even though it is smaller than its parent. It has to be a complete binary tree, meaning that we have to fill every single level before going down by 1 level. So this will not work. But a great thing with this is that we know that the smallest element is always at the top, right? And we also know that with Python there is a quite easy way to create a min heap, and this min heap will appear as an array where the top element would be the first element, so at the index 0, so we can easily return the index 0. So that will be the goal. So every time we add something, we are gonna add it to the tree, to our min heap. So let's say that we initially add, for example, 5. Well, we are gonna add 5 here. But then what if the second number that we add is 3? Well, a min heap in Python is gonna be smart enough to push this 5 back like this and add the 3 here, right? Because 3 is smaller than 5. So if we have to return the kth smallest element, and our 3 has 2 elements, and the k value we're given is 2, well, we know that if our 3 is of size 2, well, the kth smallest element is going to be the top element. So let's keep going. Let's say that we now add 8. Well, we know that our 3 has to be complete, so the 8 will become the left child. All right. What if now, after all this, we add the value 1? Okay, so what if we add the value 1? Well, all of this is going to go down by 1, and value 1 is going to go at the top. All right, just like this. And that's going to be our min heap for the moment. Let's say, for example, that we add a 4. Well, we are gonna add our 4 here as the right child of the the value 3, right? So in the example where we are given a k value of 5, so the amount of value that we have here in the min heap, um, let's say that we have to add the value minus 5. Well, technically, um, if we add minus 5, we are going to push everything back to put that minus 5 at the top, right? Because it is the smallest element. But since adding another element, we'll add a sixth element, and 6 is greater than our k value that we are looking for, because in the example I'm giving, I'm referring to a k value of 5. All right, so if we add a minus 5, well, what we want to do is basically to call the eep pop, and this is a function built within Python that would allow us to basically remove the smallest element in the tree. So this way we can always keep the biggest element that we found so far. So for example, if we have the numbers 1 to 100 in a random order and we add them to the min heap one by one, and we want to find the kth largest element, and let's say kth is 3, okay? So the largest element is going to be 100, and the second largest is going to be 99, and the third largest is going to be 98. So we know that when we are going to do our min heap, at the end, we are going to have a min heap 3 that will look like a 98 at the top. With a 99 as a child and 100 as the other child, right? And basically we know that we want to return that 98. So a min heap here is the perfect data structure, because adding a 97 will make the tree greater than that k value, right? So we're going to pop out the smallest value, and the smallest value would be 97. So we're going to keep that 98 at the top of the tree, and this is the value that we are going to return. Okay, so let's go ahead and start coding this. So first we're going to do our constructor class, and given our we're given basically k and nums is our list of integers. So let's first set that nums to a name that is closer to what we want to complete. So let's call this min heap, and we want to also declare our k. So our min heap is going to be nums, and k is going to be nums as it is given. It's going to be k as we are being given. And now the way that we are going to basically create our min heap is super simple in Python. You simply have to call heapq.heapify, which is, by the way, a big O of n time complexity operation. And within the brackets of this heapify, you are going to pass the nums list, which we are referring to as the min heap now. Okay, so after this line, we have a min heap binary tree with all the values in nums. But remember, we have to actually just keep the number of values that is equal to k. So what we're going to do is that basically while the length of that min heap, while the length of that min heap is greater than k, well, we are going to pop the smallest value of that min heap. So we are going to do the same. We're going to use the same function, so heapq, but this time we're going to use heap pop, like that, and we're going to pop min heap. And Python build this class for us, so actually we don't have to write all the logic to remove the smallest value and reorder the tree. So just calling heap pop is going to do is going to remove the smallest value and reorder the tree for us, so it is quite convenient. And after this line, we completed the constructor function, so we are ready to go for the add method. So first of all, in the add method, well, we are given a value, and that's it. So with that value, we are going to add it to the min heap with another built-in function called heap push. And after this, we want to take a look if by adding this value, we created a heap min that is a min heap that is greater than the value of k in length, because it is possible that when we add the first few values, well, the min heap is still has a length less, like, smaller than the actual k value. So in this case, we don't want to pop the smallest value of that tree. So the check that we're going to do, well, first we are going to add with the same function heap q, but this time it's going to be heap push. Okay, and inside this heap push, we have to define the min heap that we want to push the value in, and also the value that we are pushing in this min heap. So we're going to set that the min heap that we want to push in to the variable that we created in the constructor function, and the value that we want to push in is the value that we are given as params of the add function. And now this is where we check basically if the length of our min heap is greater than that k value. And this is where we want to heap pop once more. So we're gonna use heap q dot heap pop, and we are gonna set the min heap we want to pop the value from as our min heap. Okay, and after this, we are certain that the first element of the min heap is actually the smallest element among the greatest one, right? Because when we pop a value, we pop the smallest value. So among, like, the greatest value, like among the 5 greatest value, if k is 5, we want to take that smallest value. Okay, so we are going to return the first element. So the first element of min heap at the index 0. And just like this, we can submit it. We have an error. Okay. All right, so this was the first problem of the min heap series in Neetcode 150, k largest element in a stream. I hope you learned in this video, and I hope to see you in the next one.